In this lesson, we are going to discuss how to put all of the operations together when you have multiple situations happening with exponents. So to start, we have this example: 4 times the quantity a cubed times b squared times 3 times a to the negative fourth times b to the negative third. I'm going to start off by regrouping all of the different bases. So 4 and 3 are like terms in this sense because they are both coefficients. So because they don't have any exponents, they can be multiplied together. That only works because they don't have any specific exponent written. Then I have an a cubed and an a to the negative fourth. And I have a b squared and a b to the negative third. I'm going to continue to simplify now that I've regrouped things. 4 times 3 gives me 12. A cubed times a to the negative fourth means I'm going to take a to the third plus negative 4. Because they are being multiplied as bases, I can add the exponents. And finally, I'm going to take b to the 2 plus negative 3. I'm going to simplify again. 12, of course, is going to stay 12. Take a to the power of negative 1 and b to the power of negative 1 when I add 3 plus negative 4 and 2 plus negative 3. Final step, I am going to completely simplify by getting rid of my negative exponent. So I'm going to have 12 stay in the numerator, but a to the first power and b to the first power, both of which are redundant and don't need to be written, are going to be in the denominator. And my answer is 12 over a times b. Another example is 4 times r to the power of 0 raised to the fourth power. Now, a really important thing to note is that when we are dealing with a power of a power rule, the power is going to essentially distribute to every exponent inside. Now, 4, the coefficient 4, does not have an exponent written, but we imagine there is a 1 for the exponent there. Okay? So I'm going to take 4, raise it to the power of 4, and I'm going to take r to the 0th power and raise that to the power of 4. I'm essentially expanding this by distributing. Now 4 is going to have 1 times 4, which is just 4 to the fourth. And here I have r to the power of 0. Now if you recall, the 0 exponent makes any base become 1. So this here is going to be rewritten as 1 to the power of 4. And 1 to the power of anything is just 1. So I have 4 to the power of 4 times 1. I'm going to continue to simplify. I can drop that 1 because multiplying by 1 just gives me itself. And 4 to the power of 4 can be written as that, or I can actually do the multiplication, which is 4 times 4 times 4 times 4, which gives me 256 as my final simplified form. The last example in this video is 2 times x to the fourth, y to the negative fourth, z to the negative third, all divided by 3 times x squared times y to the negative third times z to the fourth. Now, 2 and 3, again, are coefficients. I'm actually going to just rewrite them here. They can't be simplified at all, so I'm just going to write 2/3. And like I did in the previous example, I'm going to regroup my x's, y's, and z's all together so I can look at what I'm actually going to be doing with each of them. So I have x to the fourth over x squared, and I have y to the negative fourth over y to the negative third. And then I have z to the negative third over, z to the negative third over z to the fourth. Now, because I am dividing, I'm using the quotient rule, I am going to subtract. My 2/3 I'm just going to bring down so I don't forget about it in my answer. I have x to the 4 minus 2 because it's exponent rule. I have y to the negative 4 minus negative 3. Be careful when you're subtracting to use parentheses so you don't miss any negatives, because that will change the answer. And I have z to the negative third minus 4. Okay? 2/3, again, bringing it down with me. x to the 4 minus 2 is just x squared. Y is going to be to negative 4 plus 3, essentially, because we use inverse, additive inverse. Negative 4 positive 3 gives me negative 1. And z, negative 3 and negative 4 combined gives me negative 7. Now I do want to simplify this so that way I have no negative exponents. This is a 2, just to be clear. 2/3. X squared is staying in the numerator, but y and z are going to go to the denominator with their exponent. I'm going to rewrite this a little bit clearer there. And y will be a positive 1, which doesn't need to be written, and z is going to be a 7 when I move it to the denominator. So I have 2x squared over 3yz to the 7th.